Alright, so we are starting back up again, and I didn't want to lead you in the wrong direction when I talked about number 5. It's not a find command, it's going to be a grep command that you're going to use for that. There's a nice little command that finds stuff inside of other files and things, and there's other, we have tr, we have find string, we have grep, we have lots of these little itsy bitsy commands. So what we're going to do now is look at file processing. File processing and string finding, which leads us to question number 5 and onward. So I just tested it out, and we do have the capability on this system. In fact, let me just take a look here real quick. I am in my, let me just do number 5 for you, so you can sort of see what it is we're looking at. And for those people who are missing, they're gonna miss out on this, but they can always watch the video, because I didn't want to lead you astray on this one. I think we need to define something in a file. So I'm going to just create a file here. I'm going to create a file, my file. And inside my file, I'm going to put Bob in here. And I'm going to put Larry in here. And I'm going to put Mo in here. And I'm going to exit the file. So I'm going to save it. And I'm going to save it to my file. So if I cat my file, I've got Bob, Larry, and Mo. So I can use like a grep command. If I type in grep, it's going to tell me all the syntax for it. Not very much. But the usage is greps with some options, a pattern perhaps, and then a file. So a simple way is to go grep Bob, capital B, and then my file. And it comes back with Bob. And I found Bob. So let me put Cindy in here. Grep Cindy, my file. And it didn't come back with anything. It didn't find anything. So this grep command is pretty powerful in terms of feedback. So to answer that question number 5, to write a command to determine whether or not the name Bob is in the file addresses, I'd create that file addresses like I created my file. And then I can run the command grep. But I'd like to show you a little bit more on grep, which is why I want to bring up the lecture material in a few minutes to kind of give you, and because we're almost going to cover translate, tr, and a couple of the other commands that go along with this. So it's helpful to have the background info on this because then you'll have a better understanding of what it is we're doing and all of the different, and that's a very simple way of answering that question. So if you're going to write the answer to that question, you can go grep space Bob space addresses. Is a very simple way. And then you'll notice down here on number 8, use the man to determine the grep command, what grep command does for you, and report on the results. Don't take, as an example, if I go man grep, we're going to have like 5 pages of stuff here. Don't take and copy all the stuff. Just copy like maybe one part of it or something. It's gonna go on until I hit quit eventually. I'm just going to quit out because it's just way too much stuff. I don't necessarily, so number 5, I gave you the answer for it to get you in the right direction in terms of what content this particular assignment is looking for. So number 6 is going to be a little bit different. You're going to write a command to display the entire file.
But defaultly it will be staying according to the alphabetical order.
We're going to, I'm sorry?
Defaultly it will be represented in alphabetical order.
No. No. If, for example, if I did a cat here, that's not going to work because it's not going to put it in alphabetical order. It's going to show me the file. I'm going to show you in a few minutes these commands. But I'm not going to give you, what I'm trying to tell you is I'm not going to give you the rest of this assignment right now. I'm going to get you in the right direction because after lunch I'm going to allow you to work on it. But I want to give you the commands before lunch so you can work on it because this is something you probably want to do without us telling us the answers. Like I gave the answer to this one. This one's pretty easy. There's actually a couple different ways of doing this one as well. You don't have to do it the way I just did it. So you'll be looking at, as an example, putting the contents of addresses in alphabetical order. How are you going to do that? You know. So there's a command that we're going to look at in a few minutes that's going to do that for you. And then using gzip to compress this file. So gzip is on here. Gzip should be on here. It is compress the data not written to terminal. So, and then the man pages, you don't necessarily have to give everything that comes up, just a brief description, like maybe one part of the man pages for that. And then it gets into the date command and the ability to format the output and determine and explain the results of the following commands. You're basically just going to run this stuff, and then you're going to determine what happens. And then in number 10, it's just, the echo command can be used with backspaces and under the tilde character, and determine and explain the results of the following commands. You're just running these commands. So I've decided to let you finish this one on your own from 5 forward. Well, actually from 6, because I just gave you 5. So this is not something I wanted, because it's just something you really pretty much have to experiment with on your own. So, are we good with the rest of assignment number 3? For those people who came in late, or some people are still not here, they'll catch up later. They can just watch the video. So. All right, so what we did, and I'm going to start in with lecture 6A, we jumped from 1 to 6A without going through the PowerPoints. If you're brand new to this, and you want to go slower, then I highly recommend looking at 2B. 2B, and let me just show you real quick what 2B is all about. Is the right one? Yes, 2B. Let me just play it so we can kind of sort of see what's in here. 2B is everything we looked at in terms of those Unix commands that we did in assignment number 1 and assignment number 2. Because so far we've gotten through 3. We haven't completed all of them yet, but you'll complete that on your own. But looking at basic shells, looking at VI, cat, which I showed you. This is the lecture material on it. CP, RM, ls, cd, move, date, make directory. So if you want more information on those commands, then this is lecture number 2. No, this is 2B, I believe. So write down 2B. And navigating with the dots and the dot dots. You're like, where did we get that from? It's in this lecture. Also, the password stuff, tricks for good passwords, recommendations, who am I, that we looked at, ls, cat, Control-C to break out of something. I've been Control-C'ing out of a couple of things, but just let you know that. I don't think Netscape is actually going to work from your DOS prompt, actually, but there are some text HTML editors, or HTML viewers, I should say. Man, looking at the man pages and showing you how to do that. Copy command, more command. We didn't just look at more, but more will separate out the output so it doesn't scroll so fast. If you use a more after the command, it'll put it in pages for you like the man pages does. So you can press the return button or continue or break or whatever, and then it will continue to show you a page at a time instead of scrolling everything in front of you so you can't see it. Because in some Unix systems you don't actually get to see the scroll on the window, and there's no window, so you can't really just scroll back up to see what you missed. It's gone from your screen. Now the communicating online, here's where we're going to get the chat, which is, as I mentioned before, write is a chat. I called it instant messaging. I really meant chat actually, but it's sending text back and forth between users, or email, which is your Pine, which is going to help you with that second assignment, or it may have been part of the third assignment, I'm not sure. Communicating, we did not cover the, well, this is an example of talk actually, which is the write command, but communication we did cover actually, but where this stuff is located, telnet, FTP, I'm going to assume because you're a modern day computer user, you've heard of the terminology of FTP, file transfer protocol, and you've heard of telnet. I'm not going to go that far down, and this is also a graduate level class, so it doesn't really matter. Complete talk session, originator, responder. If you've never seen how instant messaging works, this is an example. Going back and forth with message exchanging, talk sessions. And then here's the write command. And write is basically doing this for you. So you're writing from one terminal to another terminal. So if you wanted to know where the content for the question comes from, it's coming from this lecture. And email programs, Pine, ELM, Outlook, Eudora, some of these are outdated. So that's why I'm not going over it, because Pine is actually still useful. I think Pine is actually even on our systems. And I'm going to assume that you have used email before as well. That email comes from Linux, or Unix, I should say. So we have the mailbox on the local site. We have the domain. So, and here's our Pine. It's a menu-driven client. Yeah, a little text menu. Uses Pico as the editor. Pico is like VI and Nano. So Pico is even smaller. So allows my attachments. Obviously, main menu has got to compose or write a message, view messages, or quit. Very simple. We know about Unix logins, and we're out here. Oops, I forgot my mouse doesn't work. We're on a terminal. We have a terminal driver that you installed, SSH client, that goes to and runs application programs on your Unix system. And then we're connecting over a network, if you haven't figured that out. But that was the contents of 2B that we did not cover, but I wanted to show it to you. It's in the lecture material. We also have 4 that I did not show you on purpose, because I don't like VI. If you want to use VI, lecture number 4 is on VI. Importance of VI. It's not important to me. Powerful full screen editor. All the different modes and commands that you can possibly do with VI. It's a very short lecture. And we're done with it. Oh, that was VI. I covered VI. Look at that. Whoa, that was fast. All right, no more VI. The lecture I really want to cover right now is number 4. Excuse me, it's number 6A. Number 6A. 5 we're skipping for right now. We'll go back to number 5. 6A is on the material we're covering now, and I didn't want to brush over it with the commands. I want to actually give you a few things on it. We're going to look at pipe. So use the pipe operator to direct and redirect output. Grep, which is the one you're going to need for this assignment. Unique, what you mean? I don't know. I can't remember the assignment. You might need unique or translate. Comm, diff commands to compare 2 files. We looked at WC already, so we're not going to have to spend too much time on that, but it's the word count file. So these commands sed, tr, pr, used to manipulate files and content. So use manipulation and transformation commands. So we're going to look at these as well. And design new file processing application. I'm just going to show you an example of putting it all together. And you're going to put it together with a couple simple commands and a couple of the assignments. The next assignment, number 4, is this on steroids. It's definitely a little bit more interesting for some of you who are bored so far. So, advanced file processing skills and file processing skills in general. It's just, so everything on Unix is actually a file in concept. Drivers are files are files, outputs file, everything's a file. So when you say file processing, it's just processing, looking for stuff on Unix. So selecting the command to focus on extracting specific information from files. Well, here's a good listing here. So before we started the lecture, I ran grep, and grep selects lines or rows. So if I had a file and I put, if you hadn't noticed what I did with that file, I put a bunch of names in there. I went Larry or Bob, and then new line, Larry, new line, Mo, new line. And I grepped Bob in file, and it showed me the row that had Bob on it, is what it did. So it found Bob in the file, which is kind of a roundabout way of doing that, to kind of by line. So if I wanted to find a line, I have this huge C program. This is how it normally, well, one of the original uses of this was you had lots of source code, because we didn't have object orientation back then. And everything was like thousands of lines of code in a program. Find the line that's got Bob something or other in it. Oh my god. Grep, Bob, something or other, space. Here's the file name. Find it, and it just shows you the line. So you can kind of see what's in there. So it's a great way of finding something in a lot of garbage, or in a lot of lines of program code. So what if we want to use compare? So compare, C-O-M-M, compares those sorted files and shows differences. So I say, well, okay, what was this last file? What was the last version of this Word file that I put together? Oh no. This is actually kind of interesting. Create 2 files and then compare, and it'll tell you what's different. So, well, no, the difference will tell you what's different. Compare will tell you what's the same. So you compare the 2 files, and it shows you the difference. So you can tell what's the difference between A and B, which is the compare. Cut selects columns and fields out of there. Cut it out. Diff compares and selects the differences between the 2 files. So usually a diff is going to show a line of code. So if I write a bunch of names here and a bunch of names here, and I do a diff and I put one extra name over here, I'm going to get that one name that comes out of there. As an example. Head selects the beginning of the file. Why do I want to do a head? Because everybody puts the script on the top, or excuse me, the shell information. So I can say, what kind of file is this? Head, name of the file, Perl. Oh, okay. And then I can figure out what the line is. So give me the top line of it. Tells me what kind of script is in that file. Because none of our files actually have file extensions on them. We don't have to put file extensions on them. So how are we going to know what it is? So a lot of these commands are in existence so that we know what it is. So we can search through it. Select lines, tail, select the lines at the end of the file. What am I going to end in? Why do I want that? I want to know if it's a Unix file or if it's a DOS file. Am I going to say an end of line return? Am I going to say a special character? So I can look for that. Unique lines and shows typically proceeds by a sort. I'm going to just sort unique, and I'm going to put everything together and get rid of duplicates or something and that are crossed between two files. And then word count, lining lines in the file. You can use word count for a lot of different things. If you notice, however, when we used word count on our script that we put together, we came up with different numbers of words, but the files were the same. So if you did a compare, it probably would come back as being the same. But when we do the word count, we notice we have a difference in the word count. So it's not necessarily a good way of checking to see if this file is equivalent to this file. It may not be the same file if the word count's off by one character because someone put a space at the end of it. Technically, it's not the same if there's a space or something, but yeah, you can probably get what I'm saying. So file processing, manipulating, transferring commands, and extracting information out. Here's some other commands. So here's another list of commands. AWK invokes awk, a processing and pattern scanning language. You're going to use AWK in one of your assignments coming up. Cat concatenates files. We saw cat already. Change mod changes the security mode of the file. We've seen that one already as well. Join. So we can join two files, matching rows by rows. Join two files together. It's not concatenation. Concatenation takes one file and the other file and puts it together. Or appends. Appends adds one in there. Join's going to not necessarily join it from one file, start end to the other, start end. It's going to do it differently in terms of the pattern that you want to give it. Paste. Paste multiple files column by column. PR. Format and print. Format and print. Sorts and merges files together. So you're going to get some practice using some of these commands. This is lecture number 6A. Nice little lecture to know what the commands are doing. As a nice little reference. You can also use the man pages if you want. SED, S-E-D, edits data streams. We have that command. TR translates. You're going to use TR for a lot of stuff and deletes characters. So if I wanted to take a file that was all in lowercase and I want to make it all in uppercase, I can just translate it by a pattern. Make them all uppercase. Or if I want to take out all the words the, I can take out all the words the. Or change everything to Bob. Change Mary's name to Bob or something. So I translate. So it comes in handy. It's really nice for file processing. So here's our pipe command. It's that line that goes up and down. So it redirects the output of one command into the input of another command. So we're going to send the output of this dump of this data that comes out of this. And we're going to send it to this other command because we want the other command to do something with it. Example would be the direction of the output of ls command to the more command. So pipe operator can use to connect several different commands together. So we can go ls and then the pipe command and then more. So here's an example of, and then here it is way up here at the top. ls / etc. In fact, I'm going to do it this way. Actually, let's just do it this way so you can sort of see what I'm looking at. Because the screen's kind of small. So let me exit this one here. And I still have my Unix thing up here. So this one I'm going to run a little bit differently. Do we have an etc.? Actually, we might even have an etc. here. Let's see. I can actually run etc. So this command is a, here we go. ls. So this is a little bit bigger so you can see it. Actually, let's just do it this way so you can really see it. There we go. So we're going to run according to the slide. It's running this. It's going, etc. And then we're going to put the pipe. Here's the pipe command in here. And then we're doing sort recursively and then more. So the more gives us this more down here. And it's sorted. Is it sorted? Yep, backwards. So we're going from the last to the, we're going all the way up to A's at the bottom and along backward. Reverse sorts of the directory, and it's sorted by the alphabetical character front. So, AKA sorts. So you have one that's going to have to list the file in alphabetical order. Number 6 or 7 or something on that thing I didn't do for you. Hint, hint. The sort worked for that. Pipe in here took the ls, so I did an ls. Actually, here, I'm going to do that. Just go like this. So the ls on a directory, this part we know already. We took this output. So if we catted the file, we could take that output. If we had a list of names, here, actually, let's just do this. Oops, I ran it again. Let me change this back. Control C. Yeah, Control C will break me out of that. Where was I before? I think I was in roots. When I ran Bob, my file, let's see, cat, my file. There it is. My file's got Bob, Larry, and Mo in it. So let's see. Mo, Larry, Bob. Not to give it away, but hint, hint. So that's the answer to the next one on that homework assignment. List the contents of the addresses files in alphabetical order. Well, this is backwards, so why don't we just take out the -r? Reverse. Let's just take this out. Bob, Larry, Mo. Ascending order. So don't be afraid to use the lecture set as examples, because all the answers are in there. So, but it's not a matter of finding the answers, it's a matter of discovering the answers and figuring out if it's done with an ls command, how do I make it? Well, pipes anything. So if I cat, I'm going to get the content out. How am I going to show the content? If I did an ls, I'm just going to see the file. I want to see what's inside of the file. So I cat the file, and then I sort it out, and then I can see what happens with it. So that's this one. You can see it live here, actually. Grep. Let's take a look at grep. I showed you grep with Bob inside of the file. It does a lot more than that, actually. So it's used to search for specific patterns inside of a file. I just was looking for the word Bob, such as words or phrases, which I showed you. Also, you have wildcards that support or allow you to find different things, and increases grep's usefulness by combining it with other commands, like head or tail. So you can grep the head, look for Perl, and then use an if statement, and if it's Perl, run it with Perl. If it's not, run it with C++, or run it with C, or run it with something else. So you can actually check the file out, see what it is, run it with something, or do something else with it. Or, you know, it allows you like full capabilities with head and tail as well. Unique removes duplicate lines from a file. Compares only consecutive lines, therefore unique requires a sort input. So you have to pipe a unique, because you got to sort it somehow. Unique will also has options that allow you to generate output, contains a copy of each file that has a duplicate. So it finds the duplicates. So here's an example, and this one's got unique parts from and we're going to redirect it to inventory and then go more inventory. So we need a file called parts. So we don't really need a file called parts. I can use the file called my file. My file has Bob. You know what? Let me fix. I got a space at the end of let me put another one in here. Let me fix my file. Cindy, I'll put Cindy in here. There we go. Okay, I like that one better. Put another one in there. So, oh, you know what? Hello. Let's put Bob in here again. And let's put Larry in here again. I want to put some duplicates in here. So we have a new file that's got some duplicates in there. So to use the unique command, I have 2 Larrys and 2 Bobs and a Cindy and something else in there. Then I can go unique. Oops, if I spelled it correctly. Unique my file. Let's send it to another file. I know, I think I should misspelled unique. There's no Q, there's no UE. Yeah. There's no UE. Let's see, yes. And then I can cat another file. And I say I've got, oh, I didn't do it right. Bob, Larry, Mo, Cindy, Bob, Larry. Oh, but it put it by sets. Bob, Larry, Mo, Cindy, Bob, Larry. There's no Cindy twice. Unique failed. To remove duplicate entries and create a new file output. Where were the duplicate entries in this file? No, more is going to give me, if I do this, more another file.
It says the input should be sorted.
Yeah, it's not sorted, I know. It's the file format that's wrong, which is why I'm not getting the results that I want. Let's see. It's the same file. Well, let's take a look here. In essence, I don't have my files sorted, so I'm not going to have 5 of these, 5 of these, 5 of these. I'm not going to get 1, 1, 1. I'm going to get the whole thing repeated over again, because that's the sequence. So if I sorted it, so I had all the Bobs together, all the Larrys together, all the Mo's together, I'd get one of each that came out of it. So, bad example. I guess I need to make a car part out of it. Who knows? But so let's see. We got mufflers, shocks, alternatives. Oh no, this is going to be the unique to remove the duplicate entries to create a new file output. Unique minus U parts creates a file containing only the lines not duplicated. So the minus U would give us the non-duplicated ones. So experiment with it on your own, actually, and you'll see what happens. You'll have to do this anyway in one of the assignments. So using the comm command, used to identify duplicate lines because you're comparing. In the sorted files is the problem. You have to create a sorted file. So I did not sort that names file first. If I had sorted the file, then I had run the unique on it, then it would have pulled out the duplicates correctly. But I didn't do a sorted file. Unlike unique, it does not remove duplicates. It works with 2 files rather than 1 file. Remember, I've been working on 1 file, and I redirected the output to another file. So I take 2 files and work them together instead of 1 file, then I use compare. And then I can compare the 2. I have to sort them. Compares lines, common file 1 and file 2, and produces a column, 3-column format. 1, 2, 3 is going to be the differences, or the comparison between them. So the third is the lines found in both files. So if I have Bob, 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 Larry, Mo, nothing. They're not the same. So, difference. Attempts to determine the minimal changes needed to convert file 1 to file 2. So if I wrote 2 files and one of them differs from the other one because the other one has an extra line on the bottom of it, it's going to tell me the extra line that's on the bottom. What's the difference between these 2 files? So it's not really comparing, it's just giving me the cross between. How can I convert one to the other? So codes for the output indicate the order of the files to match. Lines, specific lines must be added or deleted. WC, we've seen this one. I used to count the number of words, lines, bytes, etc. It gives us a three results that come out of it. And if you don't specify any options, you see the count of the lines, the words, and you get them all in that order. You can actually say WC, just give me the number of words. Or, in fact, here it is here. WC, you got all three of them that come out. Number of words, number of lines, or number of characters with a minus C minus L minus W. I'm not going to bother because we've seen this stuff before. It's only the new stuff I'm going to try. Let's see, using manipulation and transformation commands. This is kind of new. So these commands, sed, tr, and pr, type them in the same way we've been doing everything else, used to edit and transform the appearance of the data before you display it or print it. Sed is like the Unix editor, allows you to make a global change to large files. So I'm probably saying it wrong. Seed, sed, I don't know. Minimum requirements for the input is an input file. You have to give it a file, and a command that lets you know what actions to apply to the file. So you have a sed, you give some actions, and then you give it a file. So you apply this to this, and it's going to translate it somehow. Sed commands have two general forms. So you're going to specify an editing command on a command line, or you're going to specify a script file that contains sed commands that you're going to apply to the file. I'm going to have you experiment with sed in the assignments along with tr. This is the next one. This is like, I think, number 4, actually, or number 4 or number 5. There's only 7 of them total, so don't freak out. And that's really what we're going to end up working on in the next weekend, actually. Next weekend we'll be working a lot more with a more advanced, not next weekend, but the following weekend, because we come back in 2 weeks. It feels like next weekend already. Translating the characters using the tr command. Tr copies the data from the standard input to the standard output. And deletes characters specified by options or patterns. So it translates. That's what I was saying, going from upper to lowercase, or removing commas, or removing spaces or something. And the patterns of the strings are sets of characters. So use the tr to convert lowercase characters to uppercase characters, if you remember it that way. PR prints it out to the standard output. You remember in the old days, you used to have printers, you just printed it out. And then all of a sudden we got fancy with Windows, and we had printer drivers, and we just click on it now, and it goes into this nice little GUI interface. Well, we can still print the manual way. So Unix people, they just print it out. You can go to a line, it can go to an I/O device, or it could go to the screen. It's really the same kind of print. It's the same output. So by default, PR formats the specified files into single column pages of 66 lines to fit on paper. You can actually set how many lines you want and how wide the lines should be, like how many spaces, how many characters on a line. So instead of fitting the format for the screen, it fits the format for a printer, a line printer, actually. So each page has 5-line header, contains a file name, its latest modification date, kind of like what, it's funny because Microsoft Windows did the Notepad, the same format. If you haven't noticed, on the top you get like the file name and the date sometimes. On the bottom you get like page number, page 2, page 3. It kind of followed with the print Unix command, which is actually kind of interesting. So here's an example at the end of this. This is sort of putting it all together. Designing a new file processing application. You don't have to do this, by the way. You don't have to put something together, but using these limited number of commands, we're going to put together an application. What's the application? Throw a menu up on the screen and have the user do some stuff. So important steps here in the development process is the design, figuring out what you want, and then determining what output you want the program to produce, and organize the files and the records and of all the information. So designing the records. In the old days, the records were the files, which is actually kind of interesting because then we went from records to databases. And we took, the databases weren't around at this time era. This database came out of this. Instead of having the files, we put those records in the tables. We had a table of records. Then we organized it in a different structure and made it searchable. And instead of using all these commands, we had SQL. We developed a language that was more uniform to query it. So that's why they said structured query language. It's a structured language. It doesn't follow all these other loose. This is not structured. Using tr, sed, all that stuff is not very structured. put it all together and make a language out of it. And we got structure. What it would do with SQL, we select all the records. We put them in ascending order, descending order. We select all of them that match this pattern content. So now you know where SQL came from. It's all these Unix commands structured together into one language that can be queried, that can be used to query a database. What's a database? A bunch of records. Bunch of records files. So instead of using the old file system, put them all together in a better structure and create a structured language for it. And there you go, you got a database. And that's the beginning of the relational database concept. Object-oriented databases are kind of different than that, but that's the relational model. Linking files with keys. That sounds familiar as well. So you have keys. You get sometimes it was the name of the file. Actually, so multiple files are joined by a key, common field, that each of the linked files share. Why? Because then you can grep all of them. If you're going to do it manually without, this is prior to databases, but it's the basis of it. So think about the concept. You put the keyword student, or let's say Bob. So here's all Bob's transcripts. Here's all Bob's registered classes. Here's Bob's information where he lives and stuff like that. And here's Bob's interests and hobbies and stuff. You find all the Bobs. You link them together. There's all the information about Bob, but it's all separated out into different files. So this is where the keys came from. Primary key, foreign key. So they're really the same concept. Another important task is the design phase. So how are you going to join the files together? Which files you're going to search together. And flexibility, gather information about multiple files comprised together. It's simple record keeping. So that's essence for a relational database system. There we go. So here's a programmer file. Here's the layout of the file. We got the file name. So this is prior to databases. Think about this all dissected out into a file structure in Unix. Still being done today, by the way. Here's some sample files. We got one that says programmer number, and we got first name, last name, middle initial, salary, all this information that's in there. And then we got some data types. It's going to be numeric or alpha. It looks like a table structure to you, doesn't it? Now you can organize files like that. File separator is going to be the colon. And the database doesn't normally have a file separator. Instead, the database engine takes care of that. And unless you export it, usually comma or space delimited these days. Here's another project file. It's a record layout underneath it. And then a couple examples of file layouts, essentially. Then you create the programmer and the project files. You actually just use Nano, create these files. You can actually put this together and it works quite well. Basic design, implement your application design by creating a bunch of files. And then you're working with the files is easy because you can create and manipulate them with VI or Emacs or Nano. And then you look at the structure in terms of the flow. What file is going to lead to what other file and what file you're going to update. And then we output the format. We format the output of the file. So here's the AWK command. It's used to prepare the formatted output. So AWK can work with a script. So you can take a script and put all the files together for all, going back to Bob and the Bob's student count and his transcripts and all the other stuff about Bob. Write a script to put all Bob's stuff together. Format it the way you want it, like a report. And then you run the script with AWK essentially. And once you have the format down, you can run it on Bob or Cindy or Mary or Larry or Mo, all those other people, and do the same thing. So how's that different from like a stored procedure or like a query that you're running over and over again on all the students? It's kind of the same concept in terms of how you're putting it together. So here are the purposes of developing a new file processing application. So primarily on the printf action of the AWK command. Where does printf come from? C. So that's the C script. So it provides a shortcut. AWK provides a shortcut to other Unix commands and things. In the little bit of window here, you got. It says in that window. Actually, maybe I can zoom in. Yeah. That's not going to allow me to zoom in. All right, so in there it says AWK minus capital F colon, and then there's a single quote. It says printf, and it's a printf command, like from C. So it's running a printf command in there. Don't worry about, we're not going to need to do this, but just show you an example of how to format the output. And then you can use the shell script to implement the application. So the shell script contains the commands to execute. Little text menu comes up. It says press 1 to do this, press 2 to do that. And the commands identify and explain the script programs use, and use the pound character to mark the comments of the script file at the beginning. Say, this program does this. Run the shell script on any shell, any system. Bash is a good one to run it on. It accepts a variety of different commands. Run the script by typing sh and then the name of the file. I didn't show you that actually. You can run a script by typing in the name of the script. You can also run a shell and a script together by typing in bash space the name of the file. Instead, or you could put bash inside of the script. We've been seeing bash inside of the script. There's actually 3 different ways of running it. Just run it by typing the name of the file. Put the script shell inside of the script. Or if you put the shell inside of the script and then you run the shell then the script, on the command line you're going to have 2 shells. So you type in bash commands, or my script's called commands. You're going to, and inside commands we have a bash. It's going to run a shell. We're going to have a shell and a shell. But this shell will exit, and then this shell will exit automatically. It's just like processes. Haven't talked about processes yet. We'll do a little bit next weekend. I'm going to give you all the kernel stuff next weekend. So, or not next weekend, but the following weekend. But long story short, you can recursively create the shells by running all these scripts and then push them back down by the script's ending. When the script ends, the shell's going to end. But you can start the shell by typing in the shell command and then start the script in the shell. That's what I was saying. I haven't shown you that. Putting it all together, combining all the pieces, you've got this large script that runs smaller scripts. So if you're going to design this, basically it's just giving you a summary of a way of putting together files to store data and then have the user manipulate the files to run an application. And people used to do this for the longest time. And they did it for a very long time before databases came out. Now most people would design a database for this because it's more efficient storage. Problem with file systems, you got files all over the place. What if you miss a file? You gotta have all Bob's stuff all over in Bob's 5 or 6 different files. You put them all together and you put it along with Larry's and Mo's and all the other stuff. It makes it more efficient, essentially. So in summary, the Unix file system commands, we can select information, we can manipulate, and we can transform or translate information. Unix removes the duplicate lines. Comm compares one file with another file. Differ tries to determine what the difference is between the 2 files and gives you the difference, so you can make the change. TR copies data read from the standard input to the standard output, substituting or deleting characters that are specified, changing characters. SED is a file editor designed to make global changes to large files. Go in and change everything in this file to do something to it. And then PR prints it to standard output. So when you design a file system application kind of program, you're creating and you're making a bunch of files and then you're writing a bunch of scripts that work with the file. Reflex application needs to produce information, store information, uses record layouts. And the record layout is sort of like the database. Then you have shell scripts that use the commands to basically identify, explain the program, creates the program logic. So I know I didn't give you very much of the specifics, and we didn't run through very many examples on TR and compare stuff, but that's what you're going to do in the assignment. So looking at our time, we got choices. Let me stop this recording.